Welcome to today's episode where we journey beyond our Earth and into the cosmos, exploring the magnificent world of stars and galaxies. In this session, we'll unravel the mysteries of the universe, starting from the birth of stars to the sprawling structures of galaxies. Whether you're gazing at a clear night sky or diving deep into the wonders of astronomy, today's lesson will ignite your curiosity and expand your understanding of the universe. Buckle up as we embark on this astronomical adventure together. Let's start with the basic building blocks of everything we see glowing in our night sky: stars. Stars are immense, luminous spheres of hot gas, primarily made up of hydrogen and helium. They form through a process called nuclear fusion in their cores, where hydrogen atoms collide and merge to create helium, producing enormous amounts of energy in the form of light and heat. Our very own sun is a star, sitting at the center of our solar system and providing the warmth and light necessary for life on Earth. Did you know that stars appear to us as tiny points of light, even though many of them are immensely larger than our planet? This is because they are incredibly far away. In fact, the closest star to Earth is Proxima Centauri, located about 4.2 light-years away. Now let's delve deeper into how stars come into existence. Stars are born in dense regions of dust and gas known as nebulae. These immense clouds in space are the nursery where stars begin their lives. The force of gravity plays a crucial role here. It pulls together material within the nebula, gradually forming a protostar. When the temperature and pressure in the core of this protostar rise high enough, reaching around 15 million degrees Celsius, nuclear fusion ignites, and a new star is born. How fascinating is that? The life cycle of a star largely depends on its mass. Lower mass stars, like the Sun, will eventually end their lives as white dwarfs, while more massive stars meet a more explosive fate, ending as supernovae. After a supernova, what remains could either be a neutron star or a black hole, depending on the mass that is left behind. Speaking of black holes, let's transition to discussing galaxies. The Milky Way, where our solar system resides, is a barred spiral galaxy of colossal size, encompassing an estimated 100 to 400 billion stars, along with planets and countless other celestial bodies. The Milky Way stretches about 100,000 light-years across and contains a supermassive black hole at its center named Sagittarius A star. When we gaze up at the night sky and see the Milky Way, it appears as a beautiful hazy band of light filled with stars. Now, the universe boasts various types of galaxies. Broadly, they can be categorized into three main types: spiral galaxies, elliptical galaxies, and irregular galaxies. Spiral galaxies, like the Milky Way, have distinct spiral arms and are typically rich in both gas and dust, encouraging active star formation. On the other hand, elliptical galaxies appear more oval or round and are formed mainly of older stars, with very little new star formation occurring. Lastly, irregular galaxies do not have a defined shape and are often distorted due to gravitational interactions with neighboring galaxies. The Andromeda Galaxy, known as M31, is a prime example of a spiral galaxy, much like our own Milky Way. Now, moving beyond individual stars and galaxies, let's shift our focus to constellations. These are groups of stars that form recognizable patterns from our viewpoint on Earth. The International Astronomical Union has documented 88 official constellations. It's important to understand that these stars, while forming a pattern, can be at vastly different distances from Earth. Constellations have not only served as a picturesque view for stargazers but also played a significant role in navigation for sailors and travelers throughout human history. For example, the Big Dipper, which is part of the Ursa Major constellation, has been a guiding point for explorers for centuries. Transitioning to the end phases of a star's life brings us to one of the most spectacular events in the universe: supernovae. Massive stars, those with more than 8 times the mass of our Sun, culminate their fascinating life cycles with an explosive end known as a supernova. This event is so intense that it can outshine entire galaxies and release more energy than the Sun will emit over its entire life. The explosion also plays a pivotal role in cosmic chemistry, scattering heavy elements like gold and silver throughout the universe, contributing to the material that forms planets and even life itself. Now, let's talk about the mysterious and intriguing black holes. These cosmic entities represent regions in spacetime where gravity becomes so strong that nothing, not even light, can escape. Black holes form when massive stars collapse at the end of their life cycles, creating what we call stellar mass black holes. What's more captivating is that supermassive black holes, which can weigh millions or even billions of times more than our Sun, are believed to exist at the centers of most galaxies, including the Milky Way. The boundary surrounding a black hole is known as the event horizon, a point of no return where the gravitational pull is inexorable. As we explore beyond our solar system, we encounter another fascinating aspect of astronomy: exoplanets. These are planets that orbit stars outside our solar system. The first confirmed exoplanet was discovered in 1992 around a pulsar, with the first Sun-like exoplanet, named 51 Pegasi b, found in 1995. Since then, over 5,000 exoplanets have been confirmed, ranging from rocky, Earth-like planets to massive gas giants larger than Jupiter. Some of these exoplanets exist in the habitable zone of their stars, where conditions might be right for liquid water to exist, raising the exciting possibility of life beyond Earth. Now, as we try to understand the properties of stars, we turn to the Hertzsprung-Russell diagram. This crucial tool plots stars based on their luminosity, which is their brightness, and their temperature, or color. Interestingly, around 88% of stars, including the Sun, are found on the main sequence of this diagram, where they are actively fusing hydrogen into helium. Off the main sequence, we have red giants that are cooler yet bright and white dwarfs that are hot but dim. Understanding this diagram helps astronomers gain insights into stellar evolution and the life cycles of stars, showing how stars grow, evolve, and ultimately end their lives. As we return to our closest star, the Sun, it's important to highlight its fundamental role within our solar system. The Sun is classified as a G-type main sequence star, also referred to as a yellow dwarf. Remarkably, it holds about 99.86% of our solar system's total mass. Its surface temperature averages about 5,500 degrees Celsius, while its core heats up to about 15 million degrees Celsius. Indeed, the energy that fuels our Sun comes from nuclear fusion, specifically a process known as the proton-proton chain. Additionally, phenomena such as sunspots, which are darker and cooler areas on the Sun's surface, result from magnetic activity. Solar flares and coronal mass ejections can even affect our planet by creating stunning auroras or disrupting satellites and power systems. The universe is a grand tapestry woven with stars, nebulae, galaxies, and black holes, calling us to explore and understand more about our existence. As we've journeyed through the life cycles of stars, the structure of galaxies, and the incredible phenomena that arise in our universe, it's clear that astronomy is not just about looking up at the stars but about understanding our place in the cosmos. Each star that twinkles above holds its own story, just like the many galaxies that stretch out into the infinite expanse of space. In today's episode, we explored the fascinating life of stars, from their birth in nebulae to their explosive deaths as supernovae. We discovered the diverse types of galaxies, including the breathtaking Milky Way and Andromeda galaxies. Our journey didn't stop there, as we learned about the intriguing phenomena of black holes, the concept of exoplanets, and the essential Hertzsprung-Russell diagram used by astronomers to study stars. Finally, we examined the Sun, the powerhouse of our solar system, and its influence on our planet. This vast universe we inhabit is full of mysteries waiting to be unraveled, reminding us that the more we learn, the more we realize there is yet to discover. Thank you for joining us on this stellar expedition through the universe. We encourage you to keep looking up and nurturing your curiosity about the cosmos. Whether you're watching the night sky or diving into educational resources, remember that the universe has endless wonders to explore. Until next time, keep questioning and discovering.